Welcome to my channel. Be it known that I, Nikola Tesla, from Smiljan, border country of Austria-Hungary, residing at New York, have invented certain new and useful improvements in electromagnetic motors, of which the following is a specification, reference being had to the drawings accompanying and forming a part of the same. The practical solution of the problem of the electrical conversion and transmission of mechanical energy involves certain requirements which the apparatus and systems heretofore employed have not been capable of fulfilling. Such a solution primarily demands a uniformity of speed in the motor irrespective of its load within its normal working limits. On the other hand, it is necessary to attain a greater economy of conversion that has heretofore existed, to construct cheaper and more reliable and simple apparatus, and, lastly, the apparatus must be capable of easy management, and such that all danger from the use of currents of high tension, which are necessary to an economical transmission, may be avoided. My present invention is directed to the production and improvement of apparatus capable of more nearly meeting these requirements than those heretofore available, and though I have described various means for the purpose, they involve the same main principles of construction and mode of operation, which may be described as follows. A motor is employed in which there are two or more independent circuits through which alternate currents are passed at proper intervals, in the manner hereinafter described, for the purpose of effecting a progressive shifting of the magnetism or of the lines of force. In accordance with the well-known theory, and a consequent action of the motor, it is obvious that a proper progressive shifting of the lines of force may be utilized to set up a movement or rotation of either element of the motor, the armature, or the field magnet, and that if the currents directed through the several circuits of the motor are in the proper direction, no commutator for the motor will be required. But to avoid all the usual commutating appliances in the system, I prefer to connect the motor circuits directly with those of a suitable alternate current generator. The practical results of such a system, its economical advantages, and the mode of its construction and operation will be described more in detail by reference to the accompanying diagrams and drawings. Figures 1 to 8 and 1a to 8a, inclusive, are diagrams illustrating the principle of the action of my invention. The remaining figures are views of the apparatus in various forms by means of which the invention may be carried into effect and which will be described in their order. Referring first to Figure 9, which is a diagrammatic representation of a motor, a generator, and connecting circuits in accordance with my invention, M is the motor, and G the generator for driving it. The motor comprises a ring or annulus, R, preferably built up of thin insulated iron rings or annular plates, so as to be as susceptible as possible to variations in its magnetic condition. This ring is surrounded by 4 coils of insulated wire symmetrically placed and designated by CCC', C'. The diametrically opposite coils are connected up so as to cooperate in pairs in producing free poles on diametrically opposite parts of the ring. The 4 free ends thus left are connected to terminals T, T, T', T' as indicated. Near the ring, and preferably inside of it, there is mounted on an axis or shaft a magnetic disc, D, generally circular in shape, but having 2 segments cut away, as shown. This disc is mounted so as to turn freely within the ring R. The generator G is of any ordinary type, that shown in the present instance having field magnets, NS, and the cylindrical armature core, A, wound with the 2 coils, BB'. The free ends of each coil are carried through the shaft a prime and connected, respectively, to insulated contact rings, BBB', B', B'. Any convenient form of collector or brush bears on each ring and forms a terminal by which the current to and from a ring is conveyed. These terminals are connected to the terminals of the motor by the wires L and L' in the manner indicated, whereby 2 complete circuits are formed, one including, say, the coils B of the generator, C prime of the motor, and the other the remaining coils B prime and CC of the generator and the motor. It remains now to explain the mode of operation of this system, and for this purpose I refer to the diagrams figures 1 to 8 and 1a to 8a for an illustration of the various phases through which the coils of the generator pass when in operation and the corresponding and resultant magnetic changes produced in the motor. The revolution of the armature of the generator between the field magnets, NS, obviously produces in the coils, BB prime alternating currents, the intensity and direction of which depend upon well-known laws. In the position of the coils indicated in figure 1, the current in the coil B is practically nil, whereas the coil B prime at the same time is developing its maximum current, and by the means indicated in the description of figure 9. The circuit including this coil. B prime may also include, say, the coils CC off the motor, figure 1a. The result, with the proper connections, would be the magnetization of the ring R prime, the poles being on the line NS. The same order of connections being observed between the coil B and the coil C prime, the latter, when traversed by a current, tend to fix the poles at right angles to the line NS of figure 1a. It results, therefore, that when the generator coils have made 1/8 of a revolution, reaching the position shown in figure 2, both pairs of coils, C and C prime, will be traversed by currents and act in opposition, insofar as the location of the poles is concerned. The position of the poles will therefore be the resultant of the magnetizing forces of the coils, that is to say, it will advance along the ring to a position corresponding to 1/8 of the revolution of the armature of the generator. In figure 3, the armature of the generator has progressed to 1/4 of a revolution. At the point indicated, the current in the coil B is maximum, while in B prime it is nil, the latter coil being in its nil, the latter coil being in its neutral position. 3. A will, in consequence, be shifted to a position 90 degrees from that at the start, as shown. I have in like manner shown the conditions existing at each successive eighth of one revolution in the remaining figures. A short reference to these figures will suffice for an understanding of their significance. Figures 4 and 4a illustrate the conditions which exist when the generator armature has completed 3/8 of a revolution. Here both coils are generating current, but the coil B prime, having now entered the opposite field, is generating a current in the opposite direction, having the opposite magnetizing effect. Hence, the resultant pole will be on the line NS, as shown. In figure 5, 1/2 of one revolution of the armature of the generator has been completed, and the resulting magnetic condition of the ring is shown in figure 5a. In this phase, coil B is in the neutral position, while coil B prime is generating its maximum current, which is in the same direction as in figure 4. The poles will consequently be shifted through 1/2 of the ring. In figure 6, the armature has completed 5/8 of a revolution. In this position, coil B prime develops a less powerful current, but in the same direction as before. The coil B, on the other hand, having entered a field of opposite polarity, generates a current of opposite direction. The resultant poles will therefore be in the line NS, figure 6a, or, in other words, the poles of the ring will be shifted along 5/8 of its periphery. Figure 7 and 7a in the same manner illustrate the phases of the generator and rings at 3/4 of a revolution, and figures 8 and 8a the same at 7/8 of a revolution of the generator. These figures will be readily understood from the generator armature. These figures will be readily understood from the foregoing. When a complete revolution is accomplished, the conditions existing at the start are re-established and the same action is repeated for the next and all subsequent revolutions. And, in general, it will now be seen that every revolution of the armature of the generator produces a corresponding shifting of the poles or lines of force around the ring. This effect I utilize in producing the rotation of a body or armature in a variety of ways, for example, applying the principle above described to the apparatus shown in figure 9. The disc D, owing to its tendency to assume that position in which it embraces the greatest possible number of the magnetic lines, is set in rotation, following the motion of the lines or the points of greatest attraction. The disc D in Figure 9 is shown as cut away on opposite sides, but this, I have found, is not essential to affecting its rotation, as a circular disc, as indicated by dotted lines, is also set in rotation. This phenomenon I attribute to a certain inertia or resistance inherent in the metal to the rapid shifting of the lines of force through the same, which results in a continuous tangential pull upon the disc, causing its rotation. This seems to be confirmed by the fact that a circular disc of steel is more effectively rotated than one of soft iron, for the reason that the former is assumed to possess a greater resistance to the shifting of the magnetic lines. In illustration of other forms of my invention, I shall now describe the remaining figures of the drawings. Figure 10 is a view in elevation and part vertical section of a motor. Figure 12 is a top view of the same with the field in section and a diagram of connections. Figure 11 is an end or side view of a generator with the fields in section. This form of motor may be used in place of that shown above. D is a cylindrical or drum armature core, which, for obvious reasons, should be split up as far as practicable to prevent the circulation within it of currents of induction. The core is wound longitudinally with two coils, E and E', the ends of which are respectively connected to insulated contact rings, D', 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 carried by the shaft A upon which the armature is mounted. The armature is set to revolve within an iron shell, R', which constitutes the field magnet or other element of the motor. This shell is preferably formed with a slot or opening, R, but it may be continuous, as shown by the dotted lines, and in this event it is preferably made of steel. It is also desirable that this shell should be divided up similarly to the armature and for similar reasons. As a generator for driving this motor, I may use the device shown in Figure 11. This represents an annular or ring armature, A, surrounded by four coils, F', F', of which those diametrically opposite are connected in series so that four free ends are left, which are connected to the insulated contact rings, B'. The ring is suitably mounted on a shaft, a prime, between the poles, NS. The contact rings of each pair of generator coils are connected to these of the motor, respectively, by means of contact brushes and the two pairs of conductors, LL and L', as indicated diagrammatically in Figure 12. Now it is obvious from consideration of the preceding figures that the rotation of the generator ring produces currents in the coils, F', which, being transmitted to the motor coils, impart to the core of the latter magnetic poles constantly shifting or whirling around the core. This effect sets up a rotation of the armature owing to the attractive force between the shell and the poles of the armature, but inasmuch as the coils in this case move relative to the shell or field magnet, the movement of the coils is in the opposite direction to the progressive shifting of the poles. Other arrangements of the coils of both generator and motor are possible, and a greater number of circuits may be used, as will be seen in the two succeeding figures. Figure 13 is a diagrammatic illustration of a motor and a generator constructed and connected in accordance with my invention. Figure 14 is an end view of the generator with its field magnets in section. The field of the motor M is produced by 6 magnetic poles, G', G', secured to or projecting from a ring or frame, H. These magnets or poles are wound with insulated coils, those diametrically opposite to each other being connected in pairs so as to produce opposite poles in each pair. This leaves 6 free ends, which are connected to the terminals T, T, T', 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 double prime, T', double prime. The armature, which is mounted to rotate between the poles, is a cylinder or disc, D, of wrought iron, mounted on the shaft A. 2 segments of the same are cut away, as shown. The generator for this motor has, in this instance, an armature, A. Wound with 3 coils, K, K prime, K double prime, at 60 degrees apart. The ends of these coils are connected, respectively, to insulated contact rings, E prime, E prime, E double prime, E double prime. These rings are connected to those of the motor in proper order by means of collecting brushes and 6 wires, forming 3 independent circuits. The variations in the strength and direction of the currents transmitted through these circuits and traversing the coils of the motor produce a steadily progressive shifting of the resultant attractive force exerted by the poles, G prime, upon the armature, D, and consequently keep the armature rapidly rotating, The peculiar advantage of this disposition is in obtaining a more concentrated and powerful field. The application of this principle to systems involving multiple circuits generally will be understood from this apparatus. Referring now to figures 15 and 16, figure 15 is a diagrammatic representation of a modified disposition of my invention. Figure 16 is a horizontal cross-section of the motor, in this case a disc, D, of magnetic metal, preferably cut away at opposite edges, as shown in dotted lines in figure 15, is mounted so as to turn freely inside 2 stationary coils, N prime N, double prime, placed at right angles to one another. The coils are preferably wound on a frame, O, of insulating material, and their ends are connected to the fixed terminals, TT, T prime, T prime. The generator G is a representative of that class of alternating current machines in which a stationary induced element is employed. That shown consists of revolving permanent or electromagnet, A, and 4 independent stationary magnets, PP prime, wound with coils those diametrically opposite to each other, being connected in series and having their ends secured to the terminals TTT prime, T prime. From these terminals, the currents are led to the terminals of the motor, as shown in the drawings. The mode of operation is substantially the same as in the previous cases, the currents traversing the coils of the motor having the effect to turn the disc D. This mode of carrying out the invention has the advantage of dispensing with the sliding contacts in the system. In the forms of motor above described, only one of the elements, the armature or the field magnet, is provided with energizing coils. It remains then to show how both elements may be wound with coils. Reference is therefore had to figure 17, 18, and 19. Figure 17 is an end view of such a motor. Figure 18 is a similar view of the generator with the field magnets in section. And figure 19 is a diagram of the circuit connections in figure 17. The field magnet of the motor consists of a ring, R, preferably of thin insulated iron sheets or bands with 8-pole pieces, G prime, and corresponding recesses, in which 4 pairs of coils, V, are wound. The diametrically opposite pairs of coils are connected in series and the free ends connected to 4 terminals, W, the rule to be followed in connecting being the same as hereinbefore explained. An armature, D, with 2 coils, EE prime, at right angles to each other, is mounted to rotate inside of the field magnet R. The ends of the armature coils are connected to 2 pairs of contact rings, DDD prime, D prime, figure 19. The generator for this motor may be of any suitable kind to produce currents of the desired character. In the present instance, it consists of a field magnet, NS, and an armature, A, with 2 coils at right angles, the ends of which are connected to 4 contact rings, BBB prime, B prime, carried by its shaft. The circuit connections are established between the rings on the generator shaft and those on the motor shaft by collecting brushes and wires, as previously explained. In order to properly energize the field magnet of the motor, however, the connections are so made with the armature coils or wires leading thereto that while the points of greatest attraction or greatest density of magnetic lines of force upon the armature are shifted in one direction, those upon the field magnet are made to progress in an opposite direction. In other respects, the operation is identically the same as in the other cases cited. This arrangement results in an increased speed of rotation. In figure 17 and 19, for example, the terminals of each set of field coils are connected with the wires to the two armature coils in such a way that the field coils will maintain opposite poles in advance of the poles of the armature. In the drawings, the field coils are in shunts to the armature, but they may be in series or in independent circuits. It is obvious that the same principle may be applied to the various typical forms of motor herein before described. Having now described the nature of my invention and some of the various ways in which it is or may be carried into effect, I would call attention to certain characteristics which the applications of the invention possess and the advantages which the invention secures. In my motor, considering for convenience that represented in figure 9, it will be observed that since the disc D has a tendency to follow continuously the points of greatest attraction, and since these points are shifted around the ring once for each revolution of the armature of the generator, it follows that the movement of the disc D will be synchronous with that of the armature A. This feature, by practical demonstrations, I have found to exist in all other forms in which one revolution of the armature of the generator produces a shifting of the poles of the motor through 360 degrees. In the particular construction shown in figure 15, or in others constructed on a similar plan, the number of alternating impulses resulting from one revolution of the generator armature is double as compared with the preceding cases, and the polarities in the motor are shifted around twice by one revolution of the generator armature. The speed of the motor will, therefore, be twice that of the generator. The same result is evidently obtained by such a disposition as that shown in figure 17, where the poles of both elements are shifted in opposite directions. Again, considering the apparatus illustrated by figure 9 as typical of the invention, it is obvious that since the attractive effect upon the disc D is greatest when the disc is in its proper relative position to the poles developed in the ring R, that is to say, when its ends or poles immediately follow those of the ring, it is clearly apparent that the speed can never exceed the arbitrary limit as determined by the generator, and also that, within certain limits at least, the speed of the motor will be independent of the strength of the current. It will now be more readily seen from the above description how far the requirements of a practical system of electrical transmission of power are realized in my invention. I secure, first, a uniform speed under all loads within the normal working limits of the motor without the use of any auxiliary regulator. Second, synchronism between the motor and generator. Third, greater efficiency by more direct application of the current, no commutating devices being required on either the motor or generator. Fourth, cheapness and simplicity of mechanical construction and economy in maintenance. Fifth, the capability of being very easily managed or controlled, and sixth, diminution of danger from injury to persons and apparatus. These motors may be run in series, multiple arc or multiple series, under conditions well understood by those skilled in the art. The means or devices for carrying out the principle may be varied to a far greater extent than I have been able to indicate, but I regard as within my invention, and I desire to secure by letters patent in general, motors containing two or more independent circuits through which the operating currents are led in the manner described. By independent, I do not mean to imply that the circuits are necessarily isolated from one another, for in some instances there might be electrical connections between them to regulate or modify the action of the motor without necessarily producing a new or different action. I am aware that the rotation of the armature of a motor wound with two energizing coils at right angles to each other has been affected by an intermittent shifting of the energizing effect of both coils through which a direct current, by means of mechanical devices, has been transmitted in alternately opposite directions. But this method or plan I regard as absolutely impracticable for the purpose for which my invention is designed. at least on any extended scale, for the reasons, mainly, that a great waste of energy is necessarily involved unless the number of energizing circuits is very great, and that the interruption and reversal of a current of any considerable strength by means of any known mechanical devices is a matter of the greatest difficulty and expense. In this application, I do not claim the method of operating motors which is herein involved, having made separate application for such method. I therefore claim the following. 1. The combination, with a motor containing separate or independent circuits on the armature or field magnet or both, of an alternating current generator containing induced circuits connected independently to corresponding circuits in the motor, whereby a rotation of the generator produces a progressive shifting of the poles of the motors, as herein described. 2. In a system for the electrical transmission of power, the combination of a motor provided with 2 or more independent magnetizing coils and an alternating current generator containing induced coils corresponding to the motor coils and circuits. Connecting directly the motor and generator coils in such order that the currents developed by the generator will be passed through the corresponding motor coils and thereby produce a progressive shifting of the poles of the motor, as herein set forth. 3. The combination, with a motor having an annular or ring-shaped field magnet and a cylindrical or equivalent armature, and independent coils on the field magnet or armature or both, of an alternating current generator having correspondingly independent coils, and circuits including the generator coils and corresponding motor coils in such manner that the rotation of the generator causes a progressive shifting of the poles of the generator causes a progressive shifting of the poles of the motor in the manner set forth. 4. In a system for the electrical transmission of power, the combination of the following instrumentalities, to wit, a motor composed of a disc or its equivalent mounted within a ring or annular field, magnet, which is provided with magnetizing coils connected in diametrically opposite pairs or groups to independent terminals, a generator having induced coils or groups of coils equal in number to the pairs or groups of motor coils, and circuits connecting the terminals of said coils, and circuits connecting the terminals of said coils to the terminals of the motor, respectively, and in such order that the rotation of the generator and the consequent production of alternating currents in the respective circuits produces a progressive shifting of the poles of the motor, as hereinbefore described. Nikola Tesla. Please like and subscribe if you would like more content like this. Thank you.